Dear saitechinfo. Today let us discuss about the screening effect. It is also called the shielding effect in D and F block elements. The screening effect refers to the reduction in the effective nuclear charge. Effective nuclear charge experienced by the outer electrons due to the repulsion caused by the inner shell electrons. Now let us try to understand the definition. Screening effect or called shielding effect. This is point number one. Screening effect is also called a shielding effect, a protective effect. Protecting from where it refers to reduction of effective nuclear charge. So you can put effective nuclear charge that is reduced. This is point number two. Experienced by the outer electrons. So this effective nuclear charge experienced by the outer electrons due to the repulsion caused by the inner shell electrons. So this is the nuclear effective nuclear charge reduction, and that is experienced by the outer electrons. That is point number three, and that is due to the repulsion caused by the inner shell electrons. Now let us try to understand this. Now here let me consider the atom, any atom. For example, let us consider iron. Its atomic number is 26. Now it has got 1s2, 2s2, 2p6, 3s2, 3p6, and you have to write down 4s2 and followed by 3d. Now 6. Now you can calculate the number of electrons, which is nothing but the atomic number. 2 plus 2, 4. 4 plus 6, 10. 10 plus 2, 12. 18, 24, 26. So the number of electrons is equal to 26. And this is the first shell. Let me call it K shell or the first energy shell, energy level. Now L shell, that is it has got 8 electron. And this third shell, that is M shell, so which has 10, 2 plus 6, 8 plus 6, 14 electrons. And finally you have 2 electrons in the outermost shell, that is in the 4. So totally 14 plus 2, 16, 17, and this is 2, 6 plus 6, 12, 12 plus 2, 14. So 2, 10, 24, 26, right? Okay. Here the problem arises. We were talking about this effective nuclear charge. What is this effective nuclear charge? Let me consider you have got the nucleus here, where you have got the protons and neutrons. And in various shells, you have the electrons. For example, in the first shell, K shell, you have 2 electrons. And in the L shell, you have got 8 electrons. And in the M shell, you have got 14 electrons. And here, 2 electrons. Now, with the increase of number of electrons, the protons are also increasing because for any neutral atom, the number of proton is equal to number of electron. So, if there are 26 electrons in iron, and that represents the atomic number, you have got the same 26 protons also. So, it means it is neutral. So, the atom is neutral. So with the increase of these, that is electron, I mean in the electronic configuration, with the increase of these energy levels, there is an increase in the effective nuclear charge also. Do you understand? For every loading of electron, there is an increase in the effective nuclear charge. But the effective nuclear charge is decreased, it is said. For example, if you got the electrons up to 8, that is 2 plus 8, up to 10, you will be having 10 protons. So there will be some effective nuclear charge. And when it goes to 26, you have got 26 protons. So the effective nuclear charge will be more, right? Because there is an attractive force between the positive and the negative electrons. So we expect more effective nuclear charge with the increase of number of electrons, right? But here you note down there is a decrease in the effective nuclear charge. Now immediately you have to question yourself, why this decrease? And this decrease that is experienced by the outer electrons. So these are the outer electrons, these 4s2 electrons, outer electrons. So here the outer electrons due to the repulsion caused by the inner shell electrons. So you have some inner shell electrons and that prevents the effective nuclear charge of the entire atom. So it gives some screening effect, a shielding effect. Okay, we used to call, for example, you've got various shell and the last shell is the ultimate shell, and before that you got the penultimate shell. Penultimate means one less, nth level, n minus 1 level. Nth level is called ultimate, n minus 1 is called the penultimate. It means the penultimate shells give some protection and thereby it shields the, that is the outermost electron, to take control by the, that is nucleus, and this effective nuclear charge is decreased drop. So what is the impact of shielding effect? The reduction in the effective nuclear charge. Are you able to understand this concept? Right. Now in D block elements, that is transition metals, and F block elements, that is inner transition metals, and they have got two groups here, that is lanthanides and actinides. So the D and F electrons are poor at shielding effect. So we have four types of electron here. What are the types? S electron, P electron, D electron, F electron. The S electron, the S orbital can have at the most two electrons. It has got the spherical shape like this, symmetric arrangement. The p orbital, it has got six electrons at the most. It means you've got px, py, pz. So simply it is represented by three boxes. And here it can be represented by one box, that is S. And what about this d orbital? It has got five types of orbital, that is dxy, dyz, dxz, dx squared minus y squared, and dz squared. Likewise, you got 14 electrons here with the seven boxes, 1, 2, 3, 4, 5, 6, and 7. Okay, so here the electrons are organized like this. This is 1s2 or simply S2. And what about this? This is 1, 2, 3, 4, 5, 6. So there are 6 electrons in the p orbital. Likewise, d orbital can have maximum 10 electrons like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And in this case, 14 electrons you can put as 7 pairs. Okay. But the pairing takes place only after filling up each orbital equally. Okay, right. Now, so what it is given here, the outer electrons compared to the outer electrons are compared to the sp electrons. That is D and F electrons are poor in shielding effect. Okay, so D and the F, that is these two, will have poor shielding effect. You can note down poor shielding. Okay, what is that? The D and the F electrons are poor shielding outer electrons, poor at shielding the outer electrons compared to the sp electrons. So sp electrons have greater shielding effect. Okay, right. So this weak shielding has major consequences in atomic and ionic sizes, ionization energies, and chemical behavior. So how many points we have got here? That is, this is the definition part, and here you have got additional points that describes the impact of this screening effect. What are the effects of this screening effect? That is, weak shielding has consequences on, that is, atomic and ionic sizes. Atomic sizes, point number one. Ionic sizes, point number two. Ionization energy, point number three. Chemical behavior, point number four. So, how these four parameters are affected because of this screening effect. And here they talk about the screening effect in two ways. One is, that is, strong screening effect. Another is poor screening effect. The strong screening effect means strong screening effect by s orbital and p orbital electrons, whereas poor screening effect or shielding effect by d orbital and f orbital. Is it clear? Right. So let me repeat once again. So this is the first, in this definition, we have the first part. What is screening effect? Second part, the types of screening effect. That is second part. Third part, what are the effects of this screening effect? So let us see one by one. Okay.